Myself Yajita from School of Pharmacy Department, PV Samani University, Surat, and today I am going to deliver the lecture about the carbonyl compounds, which is the topic of second semester BPharm. So first we have to understand what is carbonyl compound for understanding the various reaction of the carbonyl compound. So for understanding the carbonyl compound, we have to understand the terminology, what is carbonyl. So, in simple terminology, we can explain the carbonyl means carbon plus oxygen containing the double bond. So, the compounds or the structure having the C double bond O and its parent structure, these all compound we are referring as the carbonyl compounds. When we are talking about the specific compound, so as we know that the chemistry specific functional group will be present in its structure. So in its parent structure, when the specific functional group containing the C double bond O, like we can give the various example that aldehyde, ketone, carboxylic acid as well as the esters, amides. So these all are the examples of the carbonyl compound having the C double bond O in its structure. So as we can see on this slide that aldehyde, so C double bond O, one side alkyl chain will be there and one side CHO, as we know that the aldehyde means CHO. So C double bond O and H. So this is what they representing the aldehyde, and another side you will find the alkyl chain. Whereas in the case of the ketone, so we can see that on the both side alkyl chain substitution will be there and C double bond O will be there in the center of the compound. Whereas we can found in the carboxylic acid. So as we know the structural formula C double OH, so one C double bond O and hydroxyl group it is there. So C double bond O it is there. So that's why we can consider as a carbonyl compound. As well as we can find the esters in that also C double bond O. So here you can see that the C double bond O and one side the alkyl chain, and with the O also another alkyl chain which we can represent as the R1. So you can find various functional group we can consider as a carbonyl compound as it contains the C double bond O and its parent structure. Coming towards the how we can nomenclature, how we can do the IUPAC nomenclature for the specific carbonyl compound. So first we have to nomenclature the whatever alkene chain it is that first we have to understand. So depending on the number of carbon present and its parent structure, we can nomenclature the alkene like methane, ethane, propane. So, first, the name of the parent hydrocarbon is determined while counting the carbonyl carbon as a methyl group for the aldehyde, as a methylene group for the ketone. The substituents are named as it done for the hydrocarbon, as we are giving the nomenclature in the hydrocarbon chain. The name of the alkane, it is modified to the alkenyl when we are calling about the aldehyde. When we have to represent the aldehyde functional group and its parent structure with the alkane chain. So at that time we have to use the al, that is what the suffix we have to use. So we can say that alkenyl. So first we have to just split the terminology that alkenyl means alkane plus al. So al it is representing the aldehyde group as we can see here. But what about the ketone? So whenever we want to nomenclature the ketones functional group, so we can use the on, like ONE as the suffix. So alkane chain plus on. So you can say that the whatever carbon chain it is there, we are representing the alkane chain plus on. So ONE on, that is what we are representing for the ketone. So we can say that the alkanon, the position of the carbonyl group also we can denote it as the like you can say that the whatever carbon it is showing the double bond, so we can use the prefix like the on the second carbon, on the third carbon, on the fourth carbon, or the fifth number carbon. So you can use prefix. So like that we can nomenclature for the aldehyde as well as the ketone when we are talking about the carbonyl compound. So here on the next slide, you can see the various example of the aldehyde group as well as the ketone. So in the first compound, you can find that there are 5-hydroxypentanal. So as we had discussed that Al, we are mainly representing for describing the aldehyde functional group. So here you can find that on the first position, CHO group, it is that. Again, why we are calling the pentanal? So as it contains the 5 carbon chain, so that's why we are calling the pentan. As well as on the 5th carbon, you can find the hydroxy substitution is there. So that's why we are calling the 5-hydroxypentanal. Pentan, which is big alkane gel. Al, we are representing the aldehyde group. And on the 5th position, we can see the hydroxy group. As well as in the next structure, you can find two aldehyde group, it is there on the both side of its structure. So here again, when we count the carbon chain, so it is again the 5 carbon chain, so that's why we are representing the pentan. But what about the CHO group? So you can count that on the both end, on the first carbon and on the 5th carbon, you can find the CHO functional group, CHO substitution. So that's why you can find that the CHO on the first carbon also, on the 5th carbon also, and it is the 5 carbon containing chain. So that's why we are referring the pentan and 1,5-dial, as it contains the two aldehyde group in it one structure. So that's why we are representing the di, that's why we are calling the di, and al, it is representing the aldehyde. So that's why two aldehyde it is there in the structure, that's why we are calling the di al. 1,5, it is representing the position of the aldehyde group. Coming towards the next structure, so here you can find that 4 carbon chain it is there. So that's why we can say that the butane carbon chain when we are talking about the alkane. But here on the first position, you can find that the CHO group it is that. As well as you can find on the third position methyl substitution, it is there CH3. So that's why we can write 3 methyl on the third position methyl group, as well as 4 carbon chain butane, and all we are representing the CHO group. So we can write the 3 methyl butanol. Coming towards the next structure, so these all structure we are just understanding for aldehyde nomenclaturing. Now coming towards the next all structure, in the second line we can see the ketone group, it is that. So when we want to identify the ketone group, you have to find out where is the C double bond O, as we know that C double bond O, and on the both side alkyl chain will be there. So in the first structure you can find that on the second carbon, here from here you can see that the on the first carbon, second carbon C double bond O group, it is there. So we can mention the position of the double bond by using the prefix, like the numerical prefix, you can say that the on the second carbon. So you can use the 2 on we are representing the double bond C double bond O ketone group, and on second, that is what the on the second carbon we can find the C double bond O group. Now here you can find that is what the 5 carbon chain, ultimately it is the 5 carbon chain. So that's why we can use that the pentane. But here one more addition, it is that 5 carbon chain containing the one double bond, and we know that double bond, it is not called the alkane, we are representing the in alkene. So here you can find that the on the third and fourth carbon, in between the third and fourth carbon, you can find the double bond. So that's why we are calling the 3 in. As well as you can find that the on the fourth position, fourth carbon, you can find the methyl substitution. So that's why we are calling the 4 methyl. Here you can find that the 4 methyl substitution. In between the third and fourth carbon, you can find the one double bond. So that's why we are calling the 3 pentene. So here you can write pent 3 in also, as well as you can write 3 pentene also, and last one it is the 2 on. So this is what we are representing the ketone functional group. Coming towards the next structure, so here you can find that one aromatic ring structure, it is that in its parent structure. This is what the common phenyl ring structure, as you know. Coming towards the alkane chain, so here we can find that the 4 carbon it is there, so that's why we are calling the butane. Now we have to represent the number of the position of the C double bond O, so you can find on the second carbon C double bond O is there, so that's why we are calling the 2 on. And on the first position you can find the phenyl ring substitution it is there, so that's why we are writing the one phenyl, that on the first carbon phenyl ring it is there, as well as you can find on the second carbon that is the ketone group, and you can find that is what the 4 carbon chain containing structure, so that's why we are representing the butane. So you can write one phenyl on the first position, one phenyl group substitution, butane. This is what we can say that the carbon chain, number of carbon chain. And on the second position, it is the C double bond O. So that's why we are representing the 2. We are using the prefix 2, numerical prefix, for representing the C double bond O, 2 on. So this is what about the second structure. Now coming towards the next structure. So this is what you can find that this is not the aromatic ring structure. This is what the cyclic ring structure without the double bond. So here we can find that it is the cyclohexane. So when we are considering the absence of C double bond O uh, in the structure, so you can directly write the cyclohexane. But here you can find that the cyclohexanone, because here on the first position you can find that the C double bond O in its parent structure. So that's why we are using cyclohexanone, O-N-E, for representing the C double bond O. If C double bond O will not be there, you can directly use the cyclohexane. As well as when we are considering the CHO on as a first carbon, so you can find on the fourth carbon methyl substitution it is there, so that's why we are calling the 4-methyl cyclohexanone. So this is what about the IUPAC nomenclature of the aldehyde as well as the ketone compounds. So what about the compounds when the both aldehyde as well as the ketone group it is present in the single structure? So when we are finding the aldehyde and ketone both are there in the single structure, we are giving the priority to the aldehyde group. So here you can find in the uh, structure that CHO group it is also there, as well as that C double bond O it is also there. And coming towards the number of the carbon chain, how many carbon it is present? So we can say that the 5 carbon it is there. 1, 2, 3, 4 and 5 carbon chain it is there. So we can use the pentane. Clear? So here we have to represent that number of the CHO position and number of the carbon that showing the C double bond O group. So we have to find out that on the which carbon CHO group it is there and on the which carbon C double bond O group it is there. So here we are giving the priority of the aldehyde group. So first we will start the nomenclature. We will start the numbering, carbon numbering with the aldehyde functional group. So we are giving the priority to the aldehyde group. So here you can find that the CHO, that is the first carbon. So coming towards the C double bond O, so you can find that the C double bond on the fourth carbon. So we can write here 4-oxo for representing the C double bond O. Here C double bond O on the fourth carbon you can find that double bond O. So that's why we are representing the 4-oxo. As well as here, as we know that it is the 5 carbon containing chains and it contains the aldehyde group, so we are using the al pentane plus al. We are representing for the aldehyde, so pentanal, and fourth one carbon that having the C double bond O, so that's why we are calling the 4-oxopentanal. And here again you can find that second carbon, on the second carbon methyl substitution it is also there, so we can add 2-methyl 4-oxopentanal. So likewise you can do the nomenclature when we are talking about the aldehyde and ketone, both are there in the single structure. Coming towards the somewhat important physical property that we have to understand for understanding the various chemical reaction for the carbonyl compound. So that physical property, it is mainly responsible for giving the chemical reaction like aldol condensation, Cannizzaro reaction, Parkinson reaction. So these all are the chemical reaction which is based on somewhat physical properties of the carbonyl compounds. So it mainly contains the dipole moment, as oxygen it is the more electronegative than the carbon, as we know the electronegativity concept. So that oxygen it is the more electronegative when we are comparing with the carbon. This implies that the carbon is slightly positive charged and carbonyl oxygen it is slightly the negatively charged. So here you can see in the structure. So this is what we are just understanding this dipole moment. So C double bond O. So this is what you can find, C double bond O, and on the both side R and R1 substitution, that is representing the alkyl chain. So when we are coming towards the dipole moment, so somewhat electromagnetic effect you can observe when we are talking about the physical property of carbonyl compound. So what is the electromeric effect? So when we are talking about electromeric effect, so due to the presence of oxygen, which is the more electronegative atom than the carbon, so you can say that the shifting of pi electrons towards the oxygen. This is what you can say that the temporary effect you can observe in the carbonyl compound for favoring the various chemical reaction. So here that oxygen it is more electronegative. So when we are talking about the C double bond O, so as we know that it contains one sigma bond and one pi bond, and pi bond it is the weaker bond. So here that pi bond, that electron of the pi bond, it will be just attracted towards the oxygen due to the high electronegativity of the oxygen when we are comparing with the carbon. So you can write that oxygen will contain the somewhat partial negative charge. So you here we can mention the delta minus for representing the partial negative charge of oxygen, as well as see what about the carbon. So that electron it is attracting towards the oxygen. So but obvious that carbon will not getting the electron, so that's why it contains the positive charge. So we can represent the C plus, or you can say that the delta plus, C containing the positive charge and O containing the negative charge. So this is what the electromeric effect also we can say that, which is mainly found in the carbonyl compound, and which is the basic requirement for the various chemical reaction which we can observe in the carbonyl compound, like the nucleophilic addition reaction as well as the aldol condensation, cross aldol condensation, like that. So this property that making the oxygen it is slightly negatively charged, as well as the carbon it is slightly the positively charged, it is more favorable for the nucleophilic addition reaction, as well as it can be suitable for the nucleophile attack, you can say. So this is for the physical property we can find. Coming towards the electromeric effect, as we just discussed in the physical property, that electromeric effect you can say that it is the temporary effect we can found in the carbonyl compound. So when we are talking about the electromeric effect, so presence of double bond or triple bond it should be there. If your compound it not contain the pi bond, or you can say that the double bond or triple bond, you cannot found the electromeric effect, because here we are talking about the shifting of the pi electron. So that double bond or triple bond should be there, then and then only you can find that the pi electron can be shifted. So we can give the definition that electromeric effect can be defined as a temporary effect. Why we are calling the temporary effect? Because somewhat reaction, reactant plus reagent will be there. Reagent will attack on the reactant, and that reactant it is there in the negative and positive charge, or you can say that carbon and oxygen it is there with the positive and negative charge due to the electromeric effect. If it is not that, nucleophile cannot be attacked on the reactant, and so that's why you cannot found any chemical reaction. But when the reagent it is not there, in the absence of reagent, your original reactant it will again come back into its original state. So that's why we are calling the temporary effect. When the reagent it is present, you can find the electromeric effect. When the reagent it is not there, you cannot find the electromagnetic, or you can say that the partial negative charge and partial positive charge you cannot found. So here it can be the temporary effect produced when the reagent attack the multiple bonded compound, causing the complete shift of the pi electron to either of the two atoms of the bond. So here first we have to understand that two atoms of the bond, so C double bond O, or you can say that the C double bond C, it can also be that. So what is the electromagnetic effect? So you can say that C double bond O. So C, carbon and oxygen, two atoms are there. So electron can be shifted towards the carbon or oxygen. But here we can say that the oxygen, it is the more electronegative in the nature. That's why electron will be attracted towards the oxygen instead of the carbon. Clear? So that's why that oxygen will contain the partial negative charge and carbon will contain the partial positive charge. So here one example it is there, as we had already discussed that aldehyde group it is that. So CH double bond O, C double bond O, you can see here. So C double bond O, so here you can find the shifting of pi electron. So pi electron towards the oxygen. So oxygen will contain the minus charge, temporary minus charge, and carbon will contain the temporary positive charge. So you can write the like reaction like that, that instead of C double bond O, you can represent the C single bond O, and on the oxygen you can mention the minus charge for the electron, for representing the electron, and carbon that does not contain the electron, so that's why we are calling that is carbon containing the positive charge. So this is what the movement of electron from the one atom to the another atom, you can call it the electromagnetic effect. Now again we can classify the electromagnetic effect by the E1 and E2. So what is the E1 and E2, or you can say that the E plus as well as the E minus effect. So the positive electromagnetic effect occurs when the shared electron pair is transferred towards the attacking reagent. As we had discussed, the reactant will be there, reagent will be there, and you can find in between the reaction, in between the reactant and reagent, it will produce the somewhat the product. So electromagnetic up, positive electromagnetic effect when we can find, so that electron pair it will be transferred towards the attacking reagent. So here you can see in the example CH2 double bond CH2, and here the H plus it is what the attacking reagent you can find. So here H plus it will attack on the CH2 double bond CH2, but before attacking that CH2 plus CH2, it will show the electromagnetic effect. So here when we are talking about the double bond in between the alkene, so that pi electron will be shifted towards the one carbon, as here both are the carbon, no electronegativity concept is there, both are the equal carbon. So we can find that the CH2 on the one side, that pi electron shifting it is electron. So that's why we can say that the delta minus and delta plus, and we are representing the single bond. Plus H plus, so here that H plus, or you can say that the reagent, it will attack on the minus charge containing the atom. So here that electrophile will attack on the CH2 containing the, but obvious that positive charge will attract the negative charge. Here the reagent it contain the positive charge, so it will attack on the minus charge containing atom. So you can find that the here CH3 will be that. So this is what we can say, that the positive electromagnetic effect we can observe in case of the alkenes. Coming towards the negative electromagnetic effect, so that is what we had explained, that C double bond O. So in that C double bond O, that oxygen it is the more electronegative than the carbon, so that's why you can say that the oxygen it will contain the negative charge and carbon will contain the positive charge. When we are talking about the reagent, so at this time instead of the electrophile, here we are using the nucleophile. So nucleophile, it is the Cn minus. So but obvious it will attack on the positive charge. So instead of the oxygen, it will attack on the carbon, as carbon contain the positive charge. So you can see the structure here. So this is what the negative electromagnetic effect we can observe in the carbonyl compounds.